everyone for your extreme patience while we got things together over here. I'd like to thank you for taking the time to attend today's presentation. My name is Lance Zurich, and I am the product manager for the Fischer Technic Education Division over here at Studica. And today I'm going to provide you with an overview of Fischer Technic's line of pre-assembled industrial simulation and training models. Now, whether you're an educator at the high school level involved in CTE training, a college professor or industrial trainer teaching programming skills required in manufacturing, a company looking for ways to demonstrate their software-based solutions, or if you're someone who's looking for ways to make IoT-related concepts easier to understand to employees or to customers, I believe this presentation will offer some important options for you to consider. Now, let's start off by considering the skills gap. Now, if you've attended any of our other Fischer Technic education webinars, you've probably heard me discuss the importance of STEM education. Now, STEM, of course, is the acronym for science, technology, engineering, and mathematics, and it should really go without saying that STEM education has been perhaps the most discussed topic in education over the last decade. Now, as most of us are aware, the push for developing STEM skills in students is in large part to help to best prepare them to take their place in the modern workforce. Now, not so long ago when our parents or grandparents were entering the workforce, employers in areas such as manufacturing might have been satisfied with hiring workers who could demonstrate good motor skills and a solid work ethic. But as manufacturing becomes more and more dependent upon automated processes and robotic control, employers now desperately need individuals who have a background in areas such as mechatronics, industrial electricity, mechanical components, and programming PLCs. And as it ties in directly with the solutions we will be looking at in this presentation, let's consider that last skill area that I just touched upon, that of a PLC programmer. Now, first off, anyone who may not be familiar, let me explain exactly what a PLC is. The term PLC is an acronym, the letters of which stand for Programmable Logic Controller. And essentially a programmable logic controller, or again PLC, is a very specialized computer used to control the types of machines and automated processes typically found in an industrial setting, such as an automated manufacturing plant. Now, as the world of manufacturing becomes increasingly dependent upon these automated control systems, the need for workers skilled in the programming of such systems grows exponentially. So how much can PLC programmers earn? Well, to get a clear idea of just how highly prized these programming skills are, here are some salary figures for PLC programmers as quoted from job search website nuvu.com. Quote, the average PLC programmer salary in the USA is $78,000 per year or $40 per hour. Entry-level positions start at $43,924 per year, while most experienced workers make up to $132,600 per year, end quote. Now, as I prepared this webinar, I took a look at the list of current job openings for PLC programmers on nuvu.com for the date of February 27th, 2020, last year. Now, the listings at that time showed 15 positions being advertised with salaries of over $75,000. and 2 of which even listed salaries of $195,000 per year. Now, because of this trend, savvy students are increasingly enrolling in PLC training programs at the college and university level. And at the same time as this workforce of tomorrow gets their training, more and more manufacturing companies facing an urgent need right now are enrolling their incumbent workers into private training schools offering such programs. So how long does it take to learn PLC programming? Well, depending on a student's background and experience, very basic PLC programming skills can be learned in as little as 30 to 40 hours of training. Of course, to become truly proficient in all 5 of the most widely used PLC programming languages, which are listed here on the screen, as well as learning how to efficiently troubleshoot and address errors and equipment breakdowns, much more training would be required. Once again, while many students can learn PLC programming skills in a college lab setting, there are many other options available. High school CTE, career and technical education programs, of course, adult continuing ed programs, vocational training, technical training in trade schools, and employer-sponsored incumbent worker training programs. Now, that all being said, the question that still arises for the educator, whether in the university or the vocational school setting, is how do you teach PLC programming in a way that makes it engaging and relevant to the student, whatever their background? How do you get away from the dryness of textbooks and video presentations and instead make it realistic and hands-on? But there are other areas of focus beyond programming that need solutions for demonstrating, exploring, and understanding different aspects of automation and control systems. Now, it could be a company involved in creating or marketing a new type of software-based solution, looking for ways to make more tangible processes which might otherwise be perceived as abstract, or to test it out in a more realistic fashion. Maybe it's a manufacturer looking for a way to better visualize the production process for workers or stakeholders as they prepare to build a new factory. Or perhaps it's a company looking for an engaging way to demonstrate their services or solutions in a public setting, such as a trade show. Now, in each of these cases and more, there is a need for finding a solution that is engaging and which can effectively mimic and simulate real-world automated systems. And that brings us to the line of Fischer Technic industrial simulation and training models. These models have been designed with the intent of providing a compact, engaging, and hands-on method for teaching and demonstrating high-end automated systems. The line consists of a series of pre-assembled small-scale models which are designed to replicate, in both appearance and function, various automated robotic machines and systems commonly used in commercial manufacturing. But before we look at each of these models, let me provide you with just a little bit of background. Fischer Technic has been creating tools for teaching students of all ages how technology works for over 50 years, based around their unique building system. Now, what makes their building system so unique is that unlike other popular construction systems where the components are designed to simply stack, with the Fischer Technic system, it was created with more of an engineering mindset. The core building block in their system is designed to enable attachment from all 6 sides, and because of this, it allows for almost limitless design possibilities. Many of the parts are designed to slide together and lock in place using a tongue and groove assembly method, and the hundreds of different parts available also help to address very specific design needs. The Fischer Technic system was created back in the 1960s by German inventor Arthur Fischer, who's noted for countless innovations used in construction and the automotive industries. Mr. Fischer, at the time of his death in 2016, held more patents in his name than Thomas Alva Edison had amassed during his own lifetime. Now, besides Fischer Technic, Mr. Fischer was the inventor of synchronized flash photography back in 1949. As well as the creator of the expanding nylon wall plug, which is used in conjunction with a screw or a bolt to help anchor heavy objects to walls. We've all used them, of course. His company, the Fischer Group, employs thousands of individuals worldwide, producing many variations of fastening devices used in building construction. And they also produce numerous components used in automobile assembly, as well as providing consulting services to companies who wish to employ state-of-the-art manufacturing processes. Now, once again, the focus of Fischer Technic sets, whether those intended for the retail market or for classroom use, has always been on helping to foster an understanding of technology and how things work. Many of the products offered by Fischer Technic for the education sector are subject-specific sets, focusing on, for example, different STEM-related areas such as mechanics, pneumatics, robotics, or renewable energy. In many of these sets, students are asked to build a progression of models using the unique Fischer Technic system, and then perform various experiments which allow them to explore and understand aspects of that subject. Now, there are also sets designed to enable schools to offer a complete standards-focused curriculum-based program where the focus is on project-based learning. In these project-based learning programs, students dive deep into engineering and learning all aspects of the design process, which requires them to work in groups and create various devices and automated machines to meet the criteria put forth in a series of real-world scenarios based upon their own trial and error experimentation and research. The line of Fischer Technic simulation solutions, which are, of course, the focus of today's presentation, are something much different. The line consists not of kits, but of a series of pre-assembled, small-scale models which replicate in appearance and function various automated or robotic machines and systems. Models in the Fischer Technic simulation line include conveyor belts, punching machines, 3-axis pick-and-place robotic arms, color sorting lines, and even high bay warehouse storage systems. Now, besides these individual models which focus on specific automated processes, Fischer Technic also offers an integrated factory simulation model. This model consists of 4 individual workstations, a vacuum gripper robot, a high bay storage warehouse, a multi-processing station with an oven, and a sorting line with color detection, which all work together as one self-contained material cycle. Now, before we begin to look at the models in the simulation line in more detail, let me briefly outline some of the advantages of using Fischer Technic solutions. Now, I do apologize in advance, as a few of the first points that I'm going to touch on are things I mentioned before, but I think in each case it's worth repeating. First, Fischer Technic simulation solutions allow educators to offer engaging, hands-on tools for teaching, exploring, and understanding various aspects of automation and programming. Now, this can be for understanding how automated systems work, or for having a tangible physical system to observe and work with in a programming or PLC-focused learning environment. The models, once again, are designed to realistically replicate, again in both appearance and function, commonly automated systems such as conveyor belts, sorting machines, robotic arms, and much more. Now, because the models are compact and in most cases tabletop sized, they are not only ideal for use in the classroom or in-office demonstrations, but also for demonstrating software or other technology-based offerings in a trade show environment. Next, quality. Each Fischer Technic simulation model is a hand-assembled, high-quality, German-made product. Each of these models we'll look at today is available in a 24-volt version designed for use with industry-standard PLCs. Now, whether you use Allen Bradley controllers, Siemens controllers, or controllers from manufacturers such as Honeywell, Mitsubishi, General Electric, or of course many others, you can control these 24-volt versions with the PLC you prefer. Now, likewise, just as you can use your choice of controller, you can also use your preferred programming language. If you like ladder diagram or sequential function charts, you can use those. If you prefer function block or structured text or instruction list, those are all available as well. Now, please note that with these 24-volt versions, that no PLC is included with these, and that all programming, with one exception I'll touch upon, and all programming guidance, as well as any power sources or any other hardware, are the responsibility of the end user. They are not included. Of course, this shouldn't be an issue, as these models are designed again specifically for industrial users, or for those who are teaching or exploring industrial processes involving specifically PLC programming. Now, in addition, for non-industrial users and educators not versed in or familiar with PLC programming, there are several models which are also available in 9-volt variations. These 9-volt versions ship pre-wired to Fischer Technic's own proprietary robotic controllers, which are the Fischer Technic Robotics TXT controllers. And each of these controllers is pre-programmed using Fischer Technic's own RoboPro graphic programming software. With these models, the only additional component required with the 9-volt versions will be the addition of one or more 120-volt power adapters, as I will specify with each model. Otherwise, in most cases, these models should be ready to use right out of the box. If you're involved in demonstrating or exploring IoT, which is of course also known as the Internet of Things, besides the fact that many end users have adopted many of the models in the primary line of simulation and training solutions for IoT purposes, Fischer Technic also offers a special IoT-focused version of the factory simulation designed specifically for exploring and understanding cloud control and what is often referred to as Factory 4.0. Now here, the model is designed to be both controlled and monitored from a special web-based dashboard. And we will, of course, discuss this in more detail later in this presentation. Finally, Fischer Technic simulation models are cost-effective. Now, if you've had the opportunity to look into any of the other hardware-based industrial simulation options that are available in the marketplace, you'll probably notice that the entry point for many of these products can easily be $20,000 to $30,000 or even more. Fischer Technic simulation solutions, on the other hand, are available at just a fraction of that price, as well as being compact, realistic, and high-quality learning and demonstration tools. So on that note, let's look at each of the models that are available. First up will be the vacuum gripper robot. And we'll have a video here. Okay, we'll see if it lags. We'll let this catch up a second before I start talking. Yeah, it may catch up. Let's see. Now, as you'll see in this model, the vacuum gripper is a 3-axis robotic model with a vacuum gripping device. The model is designed to precisely pick up and position workpieces in 3-dimensional space. The model includes 3 encoder motors, 3 push-button limit switches, a vacuum suction device, a compressor, which is the blue brick component you'll see in the video, and a solenoid valve. The model's dimensions are approximately 9 by 19 by 15 inches, and it has a weight of about 7 pounds. The 24-volt version of this model, as well as the first 5 24-volt models that we're going to look at today, each have a relay board for motor polarity reversal and both a multi-pin connector with 34 pins and a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. Again, the 24-volt version of this model, as well as all 24-volt versions we'll look at, will require you to provide the PLC and the programming. Now, for a limited time, there is a 9-volt version available, which is the version you see in this video, which will once again come wired to the Fischer Technic Robotics TXT controller and will ship fully programmed using RoboPro graphic programming software. Now, if you did wish to create your own programming, individual licenses of RoboPro are available on our website. Otherwise, for this 9-volt version, only the addition of a single 120-volt power adapter will be required. I will mention that for this and all the other models we're going to look at today, the specs are also detailed in the products listings found on the Studica website, as well as in our product brochure, which I will provide information on obtaining at the end of this presentation. Next, we're going to look at the automated high bay warehouse. And again, I thank you for bearing with me for any video lags. This model features a transfer station with a conveyor belt, along with a shelf stacking mechanism for storing and retrieving workpiece carrier trays, and 9 individual storage spots. Components of this model include 2 encoder motors, 2 mini motors, 4 push-button limit switches, 2 photo transistors, 2 LED light barriers, and a selection of different colored workpieces, along with carrier trays for each. I will mention that this particular model is a favorite among educators I've spoken with who teach programming because it gives you a lot to work with in regards to the movements of the picker mechanism, as well as the precision required to properly store and retrieve each piece, each step which will of course require its own very specific coding. The dimensions for this model are approximately 19 by 28.5 by 15 inches, and it has a weight of approximately 18 pounds. Once again, the 24-volt version has a relay board for motor polarity reversal and both a multi-pin connector, again, 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. Again, you will need to provide your own PLC and programming. And I will mention that a limited edition 9-volt version is available at this time, which again is pre-wired to a pre-programmed robotics TXT controller. And in this case, one 120-volt power adapter will be required. Next up in our line is the multi-processing station with oven simulation. This model features a furnace simulation, which you will see in just a second, with a pneumatic sliding door. There is a downstream processing station with a pneumatic transfer unit that includes a vacuum gripper, a cutter with a rotary table, and a conveyor belt. Components used on this model include 4 mini motors, 6 push button limit switches, 2 photo transistors, 2 LED light barriers, 4 solenoid valves, and a compressor. The dimensions for this model are approximately 20 by 14 by 12 inches, and it has a weight of about 11 pounds. Again, the standard version of this model is a 24-volt version for use with the PLC of your choice, with, once again, a relay board for motor polarity reversal, and both a multi-pin connector, again 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. The limited edition 9-volt version in this case is connected to 2 robotics TXT controllers, so 2 120-volt power adapters in this case will be required for all operations. And there we go. Next up is the soaring line with color detection. We'll get rid of the sound there. This simulation features a system for detecting workpieces of different colors and sorts them via a conveyor belt into 3 different storage bins. Components on this model include 2 mini motors, 5 photo transistors, 5 LED light barriers, 3 solenoid valves, a compressor, and an optical color sensor. The dimensions for this model are approximately 20 by 14 by 12 inches, and it has a weight of about 10 pounds. Now, as with the models we've looked at before, the standard 24-volt version has a relay board for motor polarity reversal and both a multi-pin connector, again 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. Now, again, you will need to provide the PLC and the programming. And there is a limited edition 9-volt version, very limited right now, which comes again pre-wired to a pre-programmed TXT controller. And in this case, one 120-volt power adapter is required. And that's all of those. The next model is the factory simulation, which combines the 4 models that we've just reviewed. Again, the vacuum gripper robot, the automated high bay warehouse, the multi-processing station with oven, and the sorting line with color detection into one self-contained material cycle. The cycle we're going to see works like this. Work pieces are retrieved from the automated high bay warehouse using the vacuum gripper robot, and then moved to the multi-processing station with the oven. After the workpiece has been processed by this machine, it is then sorted by color in the sorting line with color detection, before again being moved by the vacuum gripper robot to the automated high bay warehouse for storage. Now, as we've already discussed the components of each model previously, I won't belabor it by restating them here, but what I do want to discuss are the dimensions of this model as a whole. As it again combines 4 individual models into one work cycle, it has a much larger footprint of approximately 39 by 31 by 16 inches, and it has a weight of between 43 and 46 pounds, depending on whether we are talking about the 24-volt version or the limited edition 9-volt version pre-wired to the TXT controllers. Now, due to these dimensions, please note that this model will only be shipped flat as freight on a pallet. And I also want to point out that as the factory simulation models tend to be in high demand, we would ask that you please anticipate a possible turnaround time of up to 3 weeks prior to any orders for this model leaving our warehouse. Now, a few other things to note. First, this is currently available in the standard 24-volt version and in very limited quantities in a 9-volt version. Now, in this instance, the 9-volt version is wired to 5 robotics TXT controllers. As such, it will require 3 120-volt power adapters. Now, as always, the 24-volt version will require the end user to provide any PLCs, all programming, and any other hardware required. Again, each station on the 24-volt version has a relay board for motor polarity reversal, and both the multi-pin connectors, again 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with pushing connections for all inputs and outputs. Now, before we move on to the next group of models, I do want to mention that there is a storage option available for those users of either of the two factory simulations we've just discussed, who might want to transport the model, or if you just want to protect it when you're not using it. Now, this travel case consists of an aluminum casemaker profile with plastic plates, and steel ball corners, as well as 4 steel tilt handles and angle protection corners. The upper section of the case is partially lined with soft foam blocks in different heights to help cushion the model, and it also has 3 internal zipper pockets for storing cables and other accessories. The lower portion is lined with hard foam. It's designed so that once the top of the travel case is removed, the model can remain in the bottom section of the case and still remain fully functional. The case itself has exterior dimensions of approximately 41 by 33 by 17 inches, and it has a weight of about 53 pounds. Now, please note that even when using the travel case, these models will still need to be shipped flat. The next model is a basic conveyor belt. Now, this is a transport belt with a length of 275 millimeters that is used to transport workpieces with a diameter of up to 29 millimeters. Multiple conveyors can easily be connected to increase the length of transport as desired. Components on this model include an excess motor, a push-button limit switch, 2 phototransistors, and 2 LED light barriers. Dimensions of this model are approximately 14 by 10 by 4 inches and it has a weight of under 2 pounds. As before, the standard 24-volt variation includes a multi-pin connector. In this case, it's 26 pins with a 2.54 millimeter grid, as seen here. And for a limited time, we also offer 9-volt versions pre-wired to the robotics TXT controller, as shown here. One 120-volt power adapter is required for operation. The next model is a variation on the conveyor belt, but which includes a punching machine. This feature is essentially the same conveyor as we just looked at, except that this time it has a machining station attached to it. Components on this model include 2 excess motors, 2 push-button limit switches, 2 phototransistors, and 2 LED light barriers. Dimensions of the model are approximately 15 by 12 by 7.5 inches with a weight of about 3.5 pounds. Again, this is available in the standard 24-volt variation with a 26-pin connector and a 2.54 grid as shown here. And for a limited time, we will be offering a 9-volt version wired to the robotics TXT controller, which requires one 120-volt power adapter for use. The next model is the indexed line with 2 machining stations. This model features a U-shaped conveyor line consisting of a milling and a drilling station and 4 conveyor belt sections. Components on this model include the 4 conveyor belts, as I just mentioned, 8 excess motors, 4 push-button limit switches, 5 phototransistors, and 5 LED light barriers. The dimensions for this model are approximately 19 by 18 by 11 inches, and it has a weight of about 8 pounds. Again, it's available in both the 24-volt version, the standard 24-volt version with a 26-pin connector and a 2.54 millimeter grid for use with PLC, and also in a limited release 9-volt version wired to the pre-programmed robotics TXT controllers and requiring one 120-volt power adapter. Next is a variation on the idea of a pick-and-place robot, which is the 3D or 3-axis robot. The 3-axis robot has gripping forceps, which it uses to help it quickly and precisely position the workpiece as it picks up in 3-dimensional space. The degrees of freedom for the robot are as follows. Axis 1 turns 180 degrees. Axis 2 can move forward or backwards 90 millimeters, and axis 3 can raise or lower 150 millimeters. Components on this model include 2 excess motors, 2 encoder motors, and 4 push-button limit switches. Dimensions of this model are approximately 19 by 16 by 9 inches, and it has a weight of about 6 pounds. Again, this comes in either a 24-volt version with a 26-pin connector and 2.54 millimeter grid designed for use with the PLC programming of your choice, or a 9-volt version, which in this case is not a limited model. This will be a standard model, and it comes pre-wired to a pre-programmed robotics TXT controller and requiring one 120-volt power adapter. Now that concludes our look at the first 9 variations of simulation models. The next pair of simulation models focuses specifically on the area of IoT and is designed for demonstrating and teaching about cloud-based monitoring and control. These models go by the name of Training Factory Industry 4.0, and these are available in both 24-volt versions for use with PLC, and also in a 9-volt variation for classroom and demonstration purposes. They've been designed to help address how the recent changes in industrial production, driven by digitization, have created a need for stronger networking and more relevant information on all production levels. Now, with this Industry 4.0 update of the existing factory simulation model, such digitization activities can be simulated, learned, and applied on a small scale before they are implemented on a larger scale. Now, as the following video showcasing the 24-volt version provides a nicely narrated overview of how the factory works, I'm going to step back for a moment and allow you to watch and listen to the narrator.
Fischer Technic Learning Factory 4.0 illustrates processes for a digitized smart factory, from delivering raw material to the finished product. Industry 4.0 applications can be tested and demonstrated using the simulation model that has already been set up. Digitization activities are simulated on a small scale and learned before they are used on a large scale. The training and simulation model demonstrates the process from the delivery, collection, and storing of the materials through the ordering and the manufacturing processes to delivering the finished product. The training factory industry is controlled by a PLC controller, a Raspberry Pi as IoT gateway, and a TXT controller. The PLC program controls the individual modules of the factory. The program is written in structured text. The PLC communicates via the standard OPC UA protocol with the Raspberry Pi, which acts as an IoT gateway to connect the factory to any cloud. The program on the Raspberry Pi is implemented in Node-RED. In Node-RED, there is an additional local dashboard available, which can be adapted to your own needs. The Raspberry Pi also communicates with the TXT controller via the standard MQTT protocol, which in turn enables access to the Fischer Technic cloud. The program on the TXT controller is executed in CC++. The sensor image data are used and monitored in the Fischer Technic cloud. The integrated WLAN router transmits factory process data to the cloud in real time. The data is presented on a web-based dashboard. 3 views are available: the customer view, supplier view, and production view. The views and data can be accessed using internet-enabled devices and can also be used remotely. The USB camera is controlled from the cloud and can view the entire factory. A sensor station measures air pressure, air quality, temperature, humidity, and brightness. The default process cycle begins with storing and identifying the material. Using RFID NFC technology, ensures that the material can be digitally traced. The integrated NFC tag stores production data that can be read out via the RFID NFC module. The cloud displays the part's color and the ID number. The vacuum gripper places suction on the material and transports it safely to the high bay warehouse. The production view on the dashboard shows where the product is in the manufacturing process. The first in, first out principle applies to outsourcing. The goods that were stored first are also the first to be removed. Ordering material is triggered online on the dashboard. The desired product and the corresponding color are selected in the customer view and then placed in the shopping cart. Customer-specific production takes place in lot size 1. The production process is simulated in 2 steps. The suction gripper passes the material on from one step to the next. The material is transferred to the sorting system once production is complete. The sorting system receives the allocation command as soon as the color sorter detects the proper color. The material is sorted using pneumatic cylinders. Production data is written on the material at the end of the production process. The finished product will be provided for collection. Instructional material and the source code for the stored programs are available online. The Fischer Technic Learning Factory 4.0 is ideally suited for education and training in vocational schools and companies, for research and teaching in colleges and universities, for development projects in IT departments, for production planners, and for demonstrating in-house software solutions at trade shows and other corporate events. The customized storage and transport case is a worthwhile add-on.
The following topics can be addressed with the Fischer Technic Training Factory Industry 4.0. Training and simulation on a realistic production model, in-depth learning through haptic comprehension, optical and sensory applications, digital traceability with NFC/RFID technology, customized production in lot size 1, integrated cloud connection and control via smart devices, using and operating dashboards, web-based remote maintenance, the linking of production and materials planning data, and the connection of upstream and downstream logistics processes. Now, as you just saw, the model incorporates many features not found in the models we previously discussed, besides just most notably the use of the cloud-based dashboard for monitoring and controlling the model. Some other examples would be the camera used for visually monitoring the factory functions from the cloud-based dashboard, as well as the environmental sensor, which collects data on variables such as temperature, air quality, humidity, and air pressure. The use of NFC chips in each individual workpiece, each of which has a unique identification number, which enable the position of each piece in the work cycle to be mapped, and the use of MQTT, message queuing telemetry transport, that allows the network TXT controllers to communicate with one another. Now, as there are 2 variations of this model, let's very briefly go over what makes them different aside from the voltage requirements. We'll begin by focusing on the 24-volt version and what makes it unique. First, it is a bit of a hybrid in that while it requires a PLC for operation and control, it does also incorporate one Fischer Technic Robotics TXT controller. The TXT controller in this case serves as the MQTT broker and interface to the Fischer Technic cloud. Communication between the PLC and TXT controller is carried out using an IoT gateway via OPC UA. OPC UA, which is also known as OPC Unified Architecture, is a standard for exchanging data across different platforms. In addition to the TXT controller used here, there is also an IoT gateway using Raspberry Pi with Node-RED. This allows the option for not only presenting and using data on a dashboard in the Fischer Technic cloud, as we just saw with the 9-volt version, but also to be able to display data and calibrate the stations of the factory in a Node-RED dashboard. The model also incorporates newly developed 24-volt adapter boards to interface to the PLC. These, of course, ship as part of the assembled training factory and are connected to the PLC via terminals. Now, among other things, the latest generation of adapter boards allows the speed of the encoder motors to be controlled via PWM, also known as pulse width modulation. And they also have push-pull output stages for phototransistors and for buttons. Finally, one of the most important new features, unlike any of the previous 24-volt models we've discussed today, the new 24-volt Training Factory Industry 4.0 also includes access to a sample program. Now, the program in this case is in structured text format, and it was created based upon a Siemens S7 1500 PLC, and this is available for download on GitHub. Of course, the new Training Factory can also be controlled with other PLC models and brands once the end user makes some small adjustments to the sample program. And the source codes needed to do so are available for download from GitHub as well. So you'll have access to all this when you purchase the model. Now, as with the first of the 24-volt models we looked at today, each of the workstations of the 24-volt variation of the Training Factory Industry 4.0 model have a relay board for motor polarity reversal and both a multi-pin connector, again 34 pins, with a grid of 2.54 millimeters, along with PCB terminals with push-in connections for all inputs and outputs. Now, all of this information and much more is included in the 152-page PDF manual, which would accompany this model. They can also be downloaded directly from the Fischer Technic website or from the Studica website. So if you go to the Studica website, if you just go under the product specs for this model, you will find a link to download this, and you're welcome to review any of the material, just to give you a heads up on everything. Now, in the case of the 9-volt version, the control is facilitated through the use of 6 robotics TXT controllers. Now, unlike all the other 9-volt versions we've looked at previously today, these ones are programmed not using RoboPro, but instead using C, C++. Again, all programming is preloaded, so that once the connections to the internet and the cloud-based dashboard are made, all of which are clearly outlined in the downloadable documentation PDF, once you've done that, you should be able to get started quickly. Now, this 9-volt version will require the addition of 3 120-volt power adapters. Of course, it will require the ability to access the internet, as well as a tablet or a device for accessing a cloud-based dashboard. Dimensions for these models are approximately 39 by 31 by 16 inches, and they have a weight of approximately 51 to 53 pounds, again, depending on the version. Now, as with the 2 factory simulation models, which we discussed previously, we do recommend the optional travel storage case to help protect your model during transport or storage. And that's the Training Factory Industry 4.0 model, again available in both 24-volt and 9-volt variations. Of course, you might well be wondering how much these models cost. So with that in mind, let's take a quick review of each option I've discussed, along with the pricing for each. First off, we have the vacuum gripper robot, the 24-volt version, again requiring PLC, $899 each. The limited edition 9-volt version, once again pre-wired to the pre-programmed robotics TXT controller, is $1,199 each. The automated high bay warehouse in the 24-volt version is $1,035. It again requires a PLC. The 9-volt version, pre-wired to the TXT controller, $1,319. The multi-processing station with oven in the 24-volt version requiring PLC, $989 each. The 9-volt version pre-wired to the TXT controller is $1,479 each. Actually, I believe that one has two. Soaring line with color detection, the 24-volt version, $819. The 9-volt version with the TXT controller is $1,129. The full factory simulation in the 24-volt version, $3,729 each. And in the 9-volt version, $5,239 each. I will reference as well that a couple of these prices I know will be going up in the coming months, so I would ask that you contact us probably for a quote soon so you can get these prices grandfathered in. When we get to the conveyor belt, the 24-volt version is $220 each, again requires PLC. The 9-volt version is $519 each. That's already, of course, wired to the TXT controller. The punching machine with conveyor belt in the 24-volt version, $289 each. The 9-volt version is $599 each. The 3D robot, again, this is one that's going to be available in the 24-volt and 9-volt versions moving forward. The 24-volt version is $829. The 9-volt version is $1,099. The indexed line with two machining stations, 24-volt version is $879. The 9-volt version is $1,399. And finally, the Training Factory Industry 4.0 for demonstrating and exploring IoT. The 24-volt version with the sample program, $7,365 each. The 9-volt version pre-programmed in C, C++, pre-wired to the TXT controllers, $6,495 each. And other items that I've touched on throughout the presentation, the 120-volt power adapters, which are required for with the powering the 9-volt models, are $12.99 each, very reasonable. The travel and storage case, which can be used for any of the factory simulation models or the Training Factory Industry 4.0 models. These are $1,000 each. So on that note, if anyone has any questions, this would be the time to use either the question and answer window, which can be found on the Zoom toolbar, the chat window, which can be found on the Zoom toolbar. Either of those will work. So if you do have any questions, you can type those in. I will mention if this is something where you're getting hit with a lot of information here as we've thrown a lot at you, that I will have my my email address up here in just a second. But if you do have any questions, you can, feel free to type away. What I will do is, while I'm waiting to see if anyone is going to type anything in, how you go about taking the next step. Well, if you would like to request a full color brochure, we're actually expecting the new brochure to be released any day now. They're just working on the new version for 2021. If you'd like to get a full color brochure and if you'd like to get current pricing, again, some of these are going up, so you may want to get us in soon. If you'd like to ask questions directly, if you'd like to request a quote, or if you'd like to speak with your dedicated educational representative, any of these things you can do by simply calling Studica directly at 888-561-7521. If you have general questions about the model, getting a quote, what have you, you can email info@studica, studica.com. If you have any questions for me specifically about anything that I've talked about with any of these models, all of these models, any aspect of Fischer Technic, whether it be the training simulation models we've looked at today or some of the other sets that I touched upon earlier, you could also email me directly. My email address is lance.zurek, lance.zurek @studica, studica.com. So on that note, I'm not seeing any questions coming up, so I'm thinking we're okay aside from the lagging of the video earlier. Again, sorry about that, and sorry about the technical difficulties at the beginning, but I hope we covered some things for you, and I hope we gave you some useful information. So again, please feel free to reach out. You can use the phone number up there, 888-561-7521. You can call me. I'm in the office from 9 a.m. to 5 p.m. Eastern Standard Time, Monday through Friday. So you can give us a call there, or feel free to email us at either of those addresses, and we'll be happy to help you out. So on that note, thank you very much for bearing with us. Thanks for taking the time to attend today. It's 4 o'clock. We're finishing up right on time. So on that note, have a great afternoon, and we look forward to speaking to you soon. Take care.